In this video, we're given two problems, and they both have a function f and a function g. We want to find f of g of x and g of f of x. That is the composition of f with g and the composition function of g with f. And then based on the results, make a conclusion. So we want to find f of 2. Just go to the f function and replace the x by 2. 2 times 3 is 6, minus 5 gives me 1. Just evaluating the function. Now we have the composition of a function with a function. Same sort of thing. So for the first one, if I want to find f of g of x is x plus 5 over 3. So replace the x and the f function by that. So this will give me 3, and in place of the x, replace it by x plus 5 over 3. Then we have the minus 5, and of course the 3, and the 3 cancel off, and then we got a plus 5 and a minus 5, that cancels. We're left with x. So that's f of g of x. Now let's reverse it. We're going to find g of f of x. F of x is 3x minus 5. So we simply do the calculation using the function g. So where I have an x for g, I replace the x by 3x minus 5. So right here I got an x, replace it by 3x minus 5. Then I got the plus 5. And then we got a 3 underneath. So minus 5 and 5 cancel. I got 3x over 3. The 3's cancel out, and I get x. And that's what we get for that one. Now it turns out we did in the last video, we were given the same two problems, f on the first one and f on the second one here. And I went through how to find the inverse function for those one-to-one functions. Well, it just turns out that this function that I named g is actually f inverse. It's the inverse function of f of x equal 3x minus 5. And that's what you can conclude. If you have two functions and you take the composition of one with the other and then switch it around, like I did here, you're always going to get x. That confirms that they are inverses, which is what we showed in the last video. So the same thing's going to happen here. For problem 2, we have f of x, and this actually here, g of x, is actually f inverse. But we named it g. You can do that. Do the first one then. Then we want to find f of g of x. So g of x is 3 to the x minus 4 plus 2. So we replace this in the f function. So this is equal to, and it's going to be the log to base 3, and you replace the x by 3 to the x minus 4 plus 2. 3 to the x minus 4 gives you replaces the x here, and then you have the minus 2 there. So the 2 and the minus 2 cancel, so this gives me the log to base 3. Obviously you have the exponential 3 to the x minus 4, so this is 3 to the x minus 4. Of course you have the plus 4 here from right there. So here, again, properties of logs, I have log to base 3 of the exponential 3 to the x minus 4. So the bases here are the same, 3 and 3. So that's always going to give you what the exponent is. You got the plus 4 over here. So this is going to give you x minus 4. And then got the plus 4 there. Minus 4 and 4 cancel, so this gives me x, which is what we're supposed to get, because these actually, like I said in the last video, we actually derived the inverse. This g of x turned out to be f inverse of x. So that checks out. And then for the reverse here, we have g of f of x. So f of x is the log to base 3 of x minus 4. And we have the plus 4 here. And this is supposed to be a minus 2 here. So in the g function, we replace the x by this expression here. So it's going to be 3. And I have an x right there. It'll be the log base 3 of x minus 4. Or I should say x minus 2. And then this is plus 4. So we're taking this expression here and replacing the x by that. So it gives me the log base 3. We got plus 4. And we have a minus 4 there. And of course you have the plus 2 out here. So this cancels out here. Because this base is 3 and this base is 3 right here. Again, properties of logarithms. This just gives me x minus 2. And we have the plus 2. Those cancel. and we get x. So again, these results simply verify that if you have a function and its inverse, and that's what we have here. I'll link the video in the description so you can also, in case you don't know how to find the inverse, but hopefully if you're at this point, you can find the inverse of a given function. But anytime you have a function and the inverse, the composition of one with the other will always give you x. Thanks for watching. We'll see you next time.